The next question is, an unknown chlorohydrocarbon has 3.55% of chlorine. Mass percentage is given. From this we can write that 100 grams of this unknown chlorohydrocarbon contains 3.55 gram of chlorine by mass. If each of the molecule of the hydrocarbon has one chlorine atom only. So let us consider this hydrocarbon has X carbon atoms and Y hydrogen atom. So they are told that it contains only one chlorine atom. So the molecular formula contains only one chlorine atom. So from this we can tell that 1 mole of this compound contains 1 mole of chlorine atom. So in this question they are asking the number of chlorine atoms present in 1 gram of chlorohydrocarbon. We have already written that 100 grams of chlorohydrocarbon contains 3.55 gram of chlorine. Then 1 gram of chlorohydrocarbon contains how many grams of chlorine? Just we can do cross multiplication and we can find the weight of chlorine. So the weight of chlorine is 3.55 multiplied by 1 divided by 100. So here we will get the answer as 0.0355 gram. But in this question, we have to find the number of chlorine atoms. To find the number of atoms, you have to multiply the number of moles into Avogadro number. Number of moles is having the formula given mass by molar mass into Avogadro number. So the given mass is the weight which we found by calculation. So number of atoms is equal to weight is 0.0355 whole divided by molar mass of chlorine is given in question 35.5 gram into Avogadro number we have to take as 6.023 into 10 power 23. So if you solve this, you will get the answer 0.001 into Avogadro number 6.023 into 10 power 23. So we can write this as 10 power minus 3 into 6.023 into 10 power 23. So when you solve the power, you will get the answer as 6.023 into 10 power 20 atoms. So the number of chlorine atoms is 6.023 into 10 power 20. So the correct option is option D. The next question is, excess of NaOH was added to 100 ml of FeCl3 resulting into 2.14 gram of FeOH twice. The molarity of FeCl3 is. So the equation for the reaction of NaOH with FeCl3 is FeCl3 plus 3NaOH gives FeOH twice plus 3NaCl. In this question, excess of NaOH is present. So NaOH is not the limiting reagent. So here the limiting reagent is FeCl3. The limiting reagent only controls the amount of product formed. So from the equation, it is clear that 1 mole of FeCl3 gives 1 mole of FeOH twice. Now in this question, 2.14 gram of FeOH twice is present. So from this we can find the number of moles of FeOH twice. Number of moles equal to given mass by molar mass. So the given mass in question is 2.14 and molar mass of FeOH twice we have to find. So FeOH twice is equal to mass of iron is 56 plus, so the mass of oxygen is 16 and for hydrogen it is 1. So 17 and 3 units of OH is there. So 17 into 3. So if we solve this, we will get 56 plus 17 into 3 is 51. So the answer is 107 gram per mole inverse. So in denominator, we have to write 107. So if we solve this, we will get the answer as 0.02 moles. Now from this equation, we have already written 1 mole of FeCl3 gives 1 mole of FeOH twice. Therefore, how many moles of FeCl3 will give 0.02 moles of FeOH thrice. So from the equation itself, the number of moles are same. So therefore, the number of moles of FeCl3 is also 0.02 moles. So we got the number of moles of FeCl3. Now in question, what are they asking? Molarity of FeCl3. Molarity formula is number of moles of solute divided by volume of solution in liter. So here molarity of FeCl3 is asked. So we have to know the number of moles of FeCl3, which we already found. So the number of moles of FeCl3 is 0.02 divided by volume of solution. The volume of solution is mentioned in question, 100 ml. 100 ml we have to convert into liter. So 100 into 10 power minus 3 liter, which is nothing but 0.1 liter. So the denominator is 0.1. So if we solve this, we will get the answer as 0.2 and the unit is capital M. So the correct option is option A, 0.2 M. The next question is 5 liters of an alkane requires 25 liters of oxygen for its complete combustion. If all volumes are measured at constant temperature and pressure, the alkane is. So we have to know the general equation for combustion of alkanes. So we will find the general equation by seeing the combustion reaction of ethane C2H6 plus in combustion an alkane is going to burn in presence of oxygen. So plus O2 gives the products of combustion are CO2 plus H2O and some amount of heat is released. Now we have to balance this equation. First, you have to balance the number of carbon atoms. In reactant side, you are having 2 carbon atoms. In product side, you are having only 1. So you have to write 2 CO2. Then you have to balance the number of hydrogen atoms. In reactant side, 6 hydrogen atoms are there. In product side, only 2. So you have to write 3 H2O. And then you have to balance the number of oxygen atoms. So if you count the number of oxygen atoms, in the product side, 7 atoms are there. 4 in CO2 molecule and 3 in H2O molecule, in 3 H2O molecule. So totally 7 atoms are there in the product side. In reactant, you are having O2, 2 atoms are there. So to balance this, you have to write 7 by 2. 7 by 2 of O2 will give 7 atoms. So from this, we are going to write the general equation of the combustion of alkane. Let us consider the number of carbon atoms as N. And from this N, we are going to write the coefficient of the other terms. So if you take the number of moles of carbon dioxide produced, it is also 2 and the number of carbon atoms is also 2. So the number of moles of CO2 is also N. Now if you see the number of moles of H2O, it is 2 plus 1 because the number of carbon atoms is 2 and number of moles of H2O is 3. So it is definitely 2 plus 1. So generally we can write number of moles of H2O is equal to N plus 1. And then if you see oxygen, so the number of moles of oxygen molecule required. So how can we get 7? N value is 2. So if we write 3N, 2 into 3 which will give 6 and we want 7, so we can add 1. So generally we can write that as 3N plus 1. So the numerator is written as 3N plus 1 and in denominator you are having 2. So this is the coefficient for the number of moles of O2, 3N plus 1 divided by 2. So this is the general equation for the combustion of alkane. So let us write that. So we know the general formula of alkanes, CN H2N plus 2 plus and the number of moles of O2 you have to write as 3N plus 1 divided by 2 of O2 gives. So the number of moles of CO2 is also N. gives NCO2 plus, and for H2O you have to write N plus 1 H2O. So this is the general equation for the combustion of alkane. So in question it is given that 5 liters of alkane requires 25 liters of oxygen. From this general equation, what can we write? 1 liter, because the coefficient of CnH2n plus 2 is 1. So 1 liter of alkane requires how many liters of O2? So the coefficient is 3n plus 1 by 2 liters of O2. Therefore, in question it is given 5 liters. 5 liters of alkane requires, just we can multiply this 3n plus 1 by 2 by 5. So it requires 3n plus 1 by 2 into 5 liters of O2. So the amount of oxygen required is 3n plus 1 by 2 into 5 liters. In question, the volume is already mentioned. So we can just equate the two values. 3n plus 1 by 2 into 5 is equal to 25, because it is mentioned in question. Now when you solve this, you will get the value of n. That value of n you can substitute in this general formula of alkane. So when you solve this, you can cancel this out. So the right hand side is 5. So when you take this 2 to the right hand side, you will get 3n plus 1 is equal to 5 into 2, 10. So 3n is equal to 9 and the value of n is 3. So if you substitute this value of n in general formula, you will get C3H2n plus 2 will become 8. C3H8 is nothing but propane. So the alkane is D-propane. The next question is, the molecular formula of a commercial resin used for exchanging ions in water softening is given. What would be the maximum uptake of Ca2 plus ions by the resin when expressed in mole per gram resin? So in water softening process using a sodium cation exchange resin, which is given in question, it involves the exchange of divalent Ca2 plus cation by the monovalent Na plus cation. So let us represent the sodium form cation exchange resin as RNA. So if we write the balanced reaction for this exchange of Na plus for the Ca2 plus ion, if we write the balanced reaction, then the reaction is Ca2 plus, which is already present in hard water, is going to react with this resin RNA and it will form R2Ca plus Na plus is released in the solution. Now if we solve or balance this equation, R2 is present in product side. So here you have to write 2 RNA. So to balance the number of sodium atoms, you have to write in product side 2 Na plus. So it is clear that from the balanced equation, 2 moles of this resin is exchanging 1 mole of Ca2 plus, because in reactant only 1 mole of Ca2 plus is present. So from the equation, 2 moles of this resin uptake 1 mole of Ca2 plus. Then 1 mole of this resin will exchange how many moles of Ca2 plus? As you can clearly see, the relation is half for the Ca2 plus and this resin. So 1 mole of this resin will uptake 1 by 2 mole of Ca2 plus. So in question they are asking to express the maximum uptake of Ca2 plus ion in mole per gram resin. So you have to express this in mole per gram. So the maximum uptake of the resin for the Ca2 plus is 1 by 2 and the mass of this resin is given as 206. So 1 by 2 whole divided by 206. So if you solve this, you will get 1 by 2 into 206, which is nothing but 1 by 412 and the unit is mole per gram, mole divided by gram. So the correct option is option B. The next question is, dissolving 120 gram of a compound of molecular weight 60 in 1000 gram of water gave a solution of density 1.12 gram per milliliter. The molarity of the solution is. So the compound which is present in small amount should be taken as the solute. So the solute is having a weight 120 gram and it is having a molecular weight 60. With this, we can find the number of moles. Number of moles is equal to given mass by molar mass. The given mass is 120. So 120 divided by the molar mass 60, which gives the number of moles as 2. Then in this question, the mass of solute is 120 gram and the mass of the solvent, that is the compound present in large amount, is taken as solvent, and here the solvent is having the mass 1000 gram. So with this we can find the mass of the total solution. Mass of the solution is equal to mass of solute plus mass of solvent. So the mass of solute is 120 gram plus mass of solvent is 1000 gram. So when you add this, you will get 1120, 1120 gram is the mass of the solution. So next is density is given. Density is equal to mass by volume. So we know the density of the solution as well as the mass of the solution also we have calculated. Now we are going to find the volume of the solution. Volume is equal to mass by density. So the mass of the solution we have calculated 1120 divided by density of the solution is given as 1.12 gram per milliliter. So here you will get the answer as, when you solve this, you will get the answer 1000 ml because density is given in ml. We know that 1000 ml is 1 liter. In this question, what we are required to find? Molarity of the solution. Molarity is equal to number of moles of solute divided by volume of solution in liters. So we have already found the number of moles of solute is 2 divided by volume of solution is 1 liter. So 2 by 1 is 2 capital M. So the answer is option B. The next question is, the amount of oxygen in 3.6 moles of water is. So in water molecule, 1 oxygen atom is present. So we can write that 1 mole of water molecule contains 1 mole of oxygen atoms. In question, 3.6 moles of water is given. Therefore, 3.6 moles of H2O contains how many moles of oxygen? So the relation is 1:1. So the answer is 3.6 moles of oxygen atoms. But in question, the amount of oxygen is asked. Amount is nothing but mass. So we know the formula of number of moles. Number of moles equal to the mass divided by the molar mass. Here the number of moles refers to number of moles of oxygen atom and the molar mass of oxygen atom is 16 gram. So with that we can find the amount. Amount equal to number of moles into mass of oxygen atom. So number of moles is 3.6 into 16. So the answer is, if you multiply this, you will get the answer 57.6 gram. So option B is the correct answer. The next question is, the density of 3M solution of sodium chloride is 1.252 gram per milliliter. The molality of the solution will be. So in this question, density of a solution is given and the molarity of the solution is also given. And that solution contains the solute sodium chloride. Molar mass of sodium chloride is also given. We have to find the molality of the solution. So the relation between molarity and molality is density is equal to molarity multiplied by 1 by molality plus the molar mass of the solute divided by 1000. So here molar mass of the solute is molar mass of sodium chloride, which is given in question itself. So just we have to substitute all the terms and we have to find the value of molality small m. So density is 1.252, which is equal to molarity is 3 into 1 by m plus m2 is given as 58.5 divided by 1000. So if you take this 3 to the left hand side, 1.252 divided by 3 is equal to 1 by m plus 58.5 divided by 1000 will give 0.0585. So you have to take this 0.0585 to the left hand side. So I will write it here. So 1.252 divided by 3 will give 0.417 minus, you have to take this to the left hand side, 0.0585, which is equal to 1 by m. So 1 by m is equal to, when you subtract this, you will get 0.3585. Now you have to take the reciprocal. M is equal to 1 divided by 0.3585, which is equal to 2.789. So the answer is 2.789. So the correct option is option C, 2.79 small m. Number of atoms in the following samples of substance is the largest in. We know the formula of number of atoms. Number of atoms equal to number of moles into Avogadro number. So here mass is given and the compound is also given. Number of moles is given mass by the molar mass into Avogadro number. So let us start from the first option. So in first option, 4 gram of hydrogen is given. So the number of moles is given mass by the molar mass. Hydrogen exists as H2. So the molar mass of H2 is 2 gram. So the given mass is 4 by 2. Number of moles is 2. 1 mole of H2 contains 2 moles of hydrogen atom. So here we have got the number of moles as 2 mole. Therefore, 2 moles of H2 contains how many moles of hydrogen atom? 2 into 2, 4 moles. 4 moles of hydrogen atom. So if we find the number of atoms is equal to 4 into Avogadro number. So if we go to the next option, 71 gram of chlorine is given. Chlorine exists as Cl2. So the molar mass of the Cl2 is 2 into 35.5. So that is 71 gram. And 1 mole of this Cl2 contains how many atoms? 2 atoms. That is 2 moles of atom of Cl2 is present. So 2 moles of Cl atom. So you just keep that in mind. So let us find the number of moles. Number of moles equal to given mass by molar mass. So the given mass is 71 divided by molar mass also we have found as 71. So the number of moles is 1. So it is clear that 1 mole contains, that is 1 mole of Cl2. 1 mole of Cl2 contains 2 moles of Cl atom. So the number of atoms is equal to number of moles into Avogadro number. So it is 2 into Avogadro number. So going to the third option, 127 gram of iodine. Iodine exists as I2. Mass of iodine is 127 and the molar mass of I2 is 254 gram. It is same as chlorine. 1 mole of this I2 contains 2 moles of iodine atom. So let us find the number of moles. N equal to given mass by molar mass, and the given mass is 127 divided by molar mass is 254. So it is 1 by 2. So the number of moles is 1 by 2, and I already told in 1 mole of I2, 2 moles of atoms are present. 2 moles of iodine atom. Therefore, we got 1 by 2 moles. 1 by 2 moles of iodine molecule contain how many atoms of iodine? So you have to see the relation 1:2. So for 1 by 2, it is 1 mole. 1 mole of iodine atom. So if we calculate the number of atoms is equal to, so the number of moles is we got as 1 into Na. So the last option is option D. In option D, 48 gram of magnesium is given. Magnesium exists as Mg only. So number of atoms we can directly calculate. Number of atoms is equal to number of moles that is given mass by the molar mass into Avogadro number. So the given mass is 48 divided by molar mass is 24. For magnesium, the molar mass is 24 into Avogadro number. So the answer is 2 into Na. So if you compare the 4 options, only for option A, you are getting the higher number of moles, 4 into Na. For option B, you are getting 2 into Na. For option C, 1 into Na. And for option D, again 2 into Na. So which is largest? Option A. So you are getting 4 into Avogadro number. So it is having the highest number of atoms. The next question is 10 ml of 2m NaOH solution is added to 200 ml of 0.5 m of NaOH solution. What is the final concentration? So here NaOH solution is present in two different concentrations, 2m and 0.5 m. So the volume added is 10 ml of the first concentration and 200 ml of the second concentration. So the final volume will be 10 ml plus 200 ml. So 10 plus 200, which will give 210 ml. So this is the final volume. In this question, we have to calculate the final concentration. We know the molarity equation. Concentration of the first solution into volume of the first solution plus concentration of the second solution into volume of the second solution is equal to the final concentration into the final volume. So with this, we can find the final concentration. So the concentration of the first solution is 2 and the volume of the first solution is 10 ml plus the concentration of the second solution is 0.5 and the volume of the second solution is 200, which is equal to, we don't know the final concentration, and the volume, that is the final volume, we have calculated as 210. So if we solve this, we can find the value of final concentration. So in left hand side, you will get 20 plus 0.5 into 200 is 100 is equal to C into 210. So here left hand side you will get 120 is equal to C into 210. So the value of C is equal to 120 divided by 210. So if we solve this, we will get the answer as 0.57 m. So the correct option is option A. The concentrated sulfuric acid that is peddled commercial is 95% H2SO4 by weight. So here the mass percentage is given as 95% H2SO4 by weight. So from this we can write that 100 grams of H2SO4 solution contains 95 grams of H2SO4 by weight. So from this statement, mass of the solution as well as the mass of the solute is known. The next part of the question tells that if the density of this commercial acid is 1.834 gram per centimeter cube, the molarity of this solution is. So the density of this solution is given. Density is equal to mass by volume. We have to find the volume of the solution. Volume is equal to mass by density. So we have found the mass of the solution as 100 gram. So 100 divided by density of the solution is given as 1.834. So if we calculate this, we will get the answer as 54.52 centimeter cube. So centimeter cube is nothing but milliliter. Now we have to convert this milliliter into liter. So it is nothing but 54.52 into 10 power minus 3 liter. So in this question, they are asking us to find the molarity. So for finding the molarity, we have to find the number of moles of the solute. So the solute in this question is H2SO4. Number of moles is equal to the amount of H2SO4 present divided by mass of H2SO4, that is molar mass. So you have to find the molar mass of H2SO4. So for hydrogen, the mass is 1 and 2 atoms are there, and for sulfur, the mass is 32. For oxygen, the molar mass is 16 and 4 atoms are there. So if you calculate this, you will get the molar mass of H2SO4 as 98 gram. So the amount of H2SO4 present is 95 divided by 98. So if you do the calculation, you will get the answer as 0.969 moles. Now the final part of the question, molarity. Molarity is equal to number of moles of the solute divided by volume of the solution in liter. So the number of moles of solute is 0.969 and the volume of the solution is 54.52 into 10 power minus 3. So when you solve this, you will get the answer 17.77 capital M. So the answer is option A, 17.8 M. The ratio of number of oxygen atoms in 16 gram of ozone, 28 gram of carbon monoxide and 16 gram of oxygen is number of oxygen atoms in 16 gram of ozone. Number of atoms is equal to number of moles into Avogadro number. Number of moles formula is given mass by molar mass into Avogadro number. So the given mass of ozone is 16 gram. 16 divided by the molar mass of ozone. 3 oxygen atoms are there. So 16 into 3, which is 48 gram. So you will get the answer as 48 for the molar mass of ozone into Na. So if you cancel this, you will get 1 by 3 Na. We know that 1 mole of O3 contains how many oxygen atoms are there? 3 oxygen atoms are there. So it contains 3 moles of oxygen atoms. Here we got 1 by 3 moles of ozone. So it contains how many moles of oxygen? 1 by 3 mole of O3 contains 3 into 1 by 3, which is 1 mole. 1 mole of oxygen atoms. So here you have to just multiply by 3 because ozone contains 3 oxygen atoms. So you have to multiply that and the answer will be 1 into Na. This is for ozone. Then we are going to 28 gram of carbon monoxide. So the number of oxygen atoms in 28 gram of CO, number of moles into Avogadro number. Number of moles is given mass by molar mass into Avogadro number. So the given mass is 28 and the molar mass of carbon monoxide 12 for carbon and 16 for oxygen. So the answer is 28 gram. So 28 divided by 28 into Avogadro number. Here you will get 1 into Na. Here 1 mole of CO. 1 mole of CO contains how many oxygen atom? It contains only 1 mole of oxygen atom. So here you have to multiply by 1. So which is the same. Now we will go to the next part. 16 gram of oxygen. So the last part is number of oxygen atoms in 16 gram of O2 oxygen molecule. Number of moles into Avogadro number. So the number of moles is given mass by the molar mass into Avogadro number. So the given mass here is 16 and the oxygen molecule is having the molar mass 16 into 2, which is nothing but 32. 16 divided by 32 into Na. So here we are getting the number of moles for the oxygen molecule as 1 by 2 into Na. Now this oxygen molecule is having how many oxygen atoms? 2 oxygen atoms are there. So you have to multiply this by 2. So the number of oxygen atoms is, this 2 will get cancelled. So it is 1 into Na. So if you see the answer for all the 3 compounds, you are having Na, Avogadro number of oxygen atoms. So the ratio is definitely 1:1:1. So option D is the correct answer. The next question is the parts per million level of fluoride ion in a 500 gram of sample of a toothpaste containing 0.2 gram of F minus is. Parts per million is having the formula mass of solute divided by mass of solution into 10 power 6. So here the solute is fluoride ion F minus. It is having the mass 0.2 gram. So 0.2 divided by the mass of solution is 500 gram. So divided by 500 into 10 power 6. So if you solve this, you will get 0.0004 into 10 power 6. This we can write as 4 into 10 power minus 4 into 10 power 6. So if you cancel the power, you will get 4 into 10 power 2. So which is nothing but 4 into 100, that is 400 parts per million. So the correct option is option A. 5 gram of benzene on nitration gave 6.6 gram of nitrobenzene. The theoretical yield of nitrobenzene will be. In this question, 5 gram of benzene give 6.6 gram of nitrobenzene is given. This 6.6 gram is the experimental yield. In this question, they are asking us to find the theoretical value of the nitrobenzene. So first you have to know the equation for the reaction between benzene and the nitric acid to form nitrobenzene. So the reaction is C6H6 plus HNO3 gives C6H5NO2. So this is nitrobenzene plus H2O. So from this equation, if you calculate mass of benzene, so the mass of benzene is, mass of one carbon is 12 and 6 atoms are there, plus mass of one hydrogen is 1 and 6 atoms are there. So 72 plus 6 is equal to 78 gram. Then if you calculate the mass of nitrobenzene, C6H5NO2, 12 into 6 plus 1 into 5 plus mass of nitrogen is 14, and for the mass of oxygen 16 and 2 atoms are there into 2. So if you calculate this, you will get the answer 123 gram. So from this equation, 78 grams of benzene yields 123 gram of nitrobenzene. So this statement we have got from the equation. Now in question, 5 gram of benzene is given. So we can compare that with the statement. 78 gram of benzene yields 123 gram of nitrobenzene. Therefore, 5 gram of benzene yields how much grams of nitrobenzene? We can find the answer by cross multiplication. So the theoretical yield. So the theoretical yield is the one which we are calculating from the equation. Theoretical yield is, you have to do cross multiplication. So 123 into 5 divided by 78. So when you do the calculation, you will get the answer as 7.88 gram. So in the given options, option C is closer to the theoretical yield. So option C, 8.09 gram is the correct answer. How many moles of magnesium phosphate Mg3PO4 twice will contain 0.25 mole of oxygen atom? So from the formula Mg3PO4 twice, how many oxygen atoms are there? 4 into 2, 8 atoms are there. 8 oxygen atoms are present. So we can tell that 1 mole of magnesium phosphate contains 8 moles of oxygen atom. Therefore, how many moles of magnesium phosphate contains 0.25 moles of oxygen atom? So we can do cross multiplication to find the number of moles x. So if you do cross multiplication, x is equal to, so 1 into 0.25 divided by, here you are having 8. So you will get the answer as 0.03125. So here the answer should be in 10 power minus 2. So you have to bring the decimal point after 2 places. So 3.125 into 10 power minus 2. So this is the number of moles of magnesium phosphate that is going to have 0.25 mole of oxygen atom. So the correct answer is option D. The next question is, if we consider that 1 by 6 in place of 1 by 12 mass of carbon atom as the relative atomic mass unit, the mass of 1 mole of the substance will. In this question, relative atomic mass is given. We know relative atomic mass. What is the need to find the relative atomic mass? We know that atoms are too small and it is difficult to find their mass directly. So that we are having a relative scale based on a standard atom. So the use of this relative scale is to convert the absolute mass of the atom into some relative scale with the standard atom. So in this relative atomic mass, the absolute mass, that is the original mass of the atom, will not change. So carbon 12 isotope is considered as the standard atom, and we define the unified atomic mass as 1/12th of the mass of carbon 12. And we know the relative atomic mass formula. Relative atomic mass is equal to average mass of atom divided by the unified atomic mass. Unified atomic mass. Now, in place of this 1/12, if we replace 1/6, only the relative atomic mass of each element will differ. But in question, they are asking mass of 1 mole of the substance. The mass of 1 mole of the substance will remain unchanged because the number of atoms in 1 mole of substance and the original mass, that is the absolute mass of each element, remains the same. So if we change the 1/12 as 1/6, only the relative atomic mass will differ, but the mass of 1 mole of the substance, which is nothing but the molar mass, will remain unchanged. 6.02 into 10 power 20 molecules of urea are present in 100 ml of its solution. The concentration of urea solution is. Here the concentration is having the unit capital M, so the concentration is expressed in terms of molarity. In this question, number of molecules are directly given. The formula of number of molecules is equal to number of moles into Avogadro number. Number of molecules is already given, so you have to find the number of moles. So if you rearrange, number of moles is equal to number of molecules divided by Avogadro number. So N is equal to number of molecules is 6.02 into 10 power 20 divided by Avogadro number is 6.02 into 10 power 23. So if you solve this, you will get the answer 10 power minus 3 moles. We have to find the concentration of solution in molarity. Molarity is equal to number of moles of the solute divided by volume of the solution. Number of moles of the solute we have already found as 10 power minus 3, and volume of solution is given in question as 100 ml. 100 ml is 0.1 liter, which we can write as 10 power minus 1 liter. So 10 power minus 3 divided by 10 power minus 1, which gives 10 power minus 2 capital M, which we can write as 0.01 M. So the correct option is option B. 25 ml of a solution of barium hydroxide on titration with a 0.1 molar solution of hydrochloric acid gave a titer value of 35 ml. So in acid-base titration, the substance with known concentration is taken in the burette. Here the substance with known concentration is hydrochloric acid, HCl, and for that the concentration is given as 0.1 molar. So it is given in molarity. Usually titrations are carried out by seeing the concentration in normality. So you have to convert this molarity. For that, the formula is normality is equal to molarity into basicity of acid. If it is an acid, you have to consider the basicity of acid, and in case of base, you have to see the acidity of base. Basicity of acid is nothing but number of ionizable H plus ion. In HCl, the basicity is 1. So the normality of the known solution is, molarity is given as 0.1. 0.1 into basicity is also 1. So the normality is 0.1 N. Here the titer value is given as 35 ml. This titer value is the volume of HCl consumed in this reaction. So V2 35 ml. So this normality is taken as N2. N2 is 0.1 N. In this question, they are asking us to find the molarity of barium hydroxide solution. For this barium hydroxide, the volume is given as 25 ml. So this is V1. So we have to use the equation of normality. N1 V1 is equal to N2 V2. So N1 is the normality of barium hydroxide solution, which we don't know, and V1 is the volume of barium hydroxide 25, and N2 is the normality of HCl, which we found 0.1, and V2 is the volume of HCl used in the reaction, that is 35. So N1 is equal to 0.1 into 35 divided by 25. So here you will get the answer as 0.14 N. So we found the normality of barium hydroxide. But in question they are asking to find the molarity of barium hydroxide. So already we told that normality is equal to molarity into, for base you have to see the acidity of base, that is the number of ionizable OH minus ion. Barium hydroxide is having 2 ionizable OH minus ion. It is having the formula BaOH twice. So normality is 0.14 is equal to molarity into 2. So you have to find the molarity. So if you rearrange this, you will find the molarity of BaOH. Molarity is equal to, you have to take the 2 to that side. 0.14 divided by 2, which is nothing but 0.07 capital M. So the correct option is option D. The next question is, with increase of temperature, which of these changes? Molality, weight fraction of solute, molarity and mole fraction. So out of the 4 given options, molarity changes with temperature because formula of molarity is equal to number of moles of solute by volume. So it depends on volume. Molarity is inversely proportional to volume. So we know that volume depends on temperature. Volume is directly proportional to temperature. This is according to Charles' law. So when temperature increases, the volume also increases, and therefore the molarity decreases. So which of these changes? The answer is option C, molarity. Number of atoms in 558.5 grams of Fe is, number of atoms is equal to number of moles into Avogadro number, which is equal to number of moles is given mass by the molar mass into Avogadro number. So the given mass in question is 558.5 and the molar mass of iron is 55.85 into Na. If you solve this, you will get 10 into Na. So the number of atoms is 10 Na. So in option, different elements are given. First option is twice that of 60 gram of carbon. So you have to find the number of atoms of 60 gram of carbon. Number of carbon atoms is equal to number of moles into Avogadro number. So we know the formula of number of moles, given mass by molar mass. 60 divided by molar mass of carbon is 12. So if you solve this, 60 by 12 will give 5 into Avogadro number. So in first option, it is given twice that of 60 gram of carbon, which is correct because 60 gram of carbon is having the number of atoms 5 Na. So it is twice that of the number of atoms in 60 gram of carbon. So 5 into 2 will give 10 Na. So the first option is itself the correct answer. If you see the next option, you have to cross check that. So what is 10 Na? 10 into 6.023 into 10 power 23. So when you multiply this 10 to the power, it will become 6.023 into 10 power 24. But in option B, 22 is given, which is wrong. Then in option C, half that in 8 gram of helium is given. So the molar mass of helium is 2. So the number of helium atoms is equal to number of moles into Avogadro number. So the number of moles is given mass by molar mass into Avogadro number. So the given mass is 8. 8 by 2 into Na, which will give 4 Na. And what is half of that number of atoms? 4 by 2 will give 2 Na, which is not equal to 10 Na. So option C is also wrong. Then in option D, it tells that 558.5 into 6.023 into 10 power 23, which is wrong, because in place of 558.5, we are having 10. So option D is also wrong. So the correct answer is option A. 5 moles of AB2 weight 125 into 10 power minus 3 kilogram. 125 into 10 power minus 3 kilogram, when you convert into gram, 125 into 10 power minus 3 into 10 power 3 gram. So the power will get cancelled, which is nothing but 125 gram. So this mass is nothing but 125 gram. And 10 moles of A2B2 weight 300 into 10 power minus 3 kilogram, which is nothing but 300 gram. The molar mass of A and molar mass of B in kilogram per mole are. So here you have to find the molar mass in terms of kilogram. So with the given information, when you calculate the number of moles of AB2, you have to know the molar mass of AB2. So the molar mass of AB2 can be considered as molar mass of A plus 2 B atoms are there. So 2 into molar mass of B. In that similar way, molar mass of A2B2 can be considered as 2 Ma plus 2 Mb. So with that, in question it is given that 5 moles of AB2 is there. So we know the number of moles formula, N equal to given mass by the molar mass. So N value is 5 and the given mass in question is 125. So we have converted it into gram. So it is 125 gram divided by molar mass is Ma plus 2 Mb. So if you take this Ma plus 2 Mb to the left hand side, you will get Ma plus 2 Mb is equal to 125 divided by 5, which is nothing but 25. So in that similar way, if you calculate for 10 moles of A2B2, so N is equal to given mass by molar mass, 10 is equal to the given mass is 300 gram. 300 divided by molar mass is 2 Ma plus 2 Mb. So if we take that to the left hand side, 2 Ma plus 2 Mb is equal to 300 by 10, which is nothing but 30. So we got two equations. When we solve these two equations, we will get the value of Ma. So the first equation is Ma. So we will write the second equation first. 2 Ma plus 2 Mb is equal to 30. Then Ma plus 2 Mb is equal to 25. So if you subtract these two equations, you will get Ma and these 2 Mb will be cancelled is equal to 30 minus 25 is 5. So the mass of Ma is equal to 5 gram, but you have to write in terms of kilogram. So Ma is equal to 5 into 10 power minus 3 kilogram per mole. Then if you want to find Mb, you can use this equation. So Ma is 5. 5 plus 2 Mb is equal to 25. 2 Mb is equal to 25 minus 5, which is nothing but 20. So Mb value is 20 by 2, 10 gram. So it is 10 into 10 power minus 3 kilogram per mole. So the correct option in which Ma is 5 is given is option D. So the correct answer is option D.